Final presenter, I should say, for today's webinar is Dr. Melinda McClellan with the United States Army Corps of Engineers. Dr. McClellan is a chemist with the Corps Environmental and Munitions Center of Expertise. She's an active member of the Environmental Data Quality Work Group, the EDQW, where she chairs the Data Review and Management Subgroup. She is the technical manager for the FUDSChem program and provides guidance and technical support for chemical sampling and analysis and data quality across USACE programs. Dr. McClellan received her PhD in analytical chemistry from the University of Illinois at Urbana-Champaign in 2014, her BS in chemistry from Florida State University in 2009, and prior to joining the EMCX, she worked for the Navy's Laboratory Quality and Accreditation Office. She also has experience in commercial, environmental, and industrial laboratory analysis and management, as well as experience in professional and college classroom instruction. So with that, I will turn it over to Dr. McClellan.
We can't hear you yet, Melinda.
Yep. I was getting ready to say the same. We cannot hear you yet.
Okay, now can you hear me?
Yes.
We can hear you now.
Yes, and this is why we connect to audio with multiple devices, because sometimes one just decides, no, not going to work today. Okay, so we have heard so much really cool stuff today. And also, can you see my screen? Right? You can see it. Okay.
Yes.
Hopefully it's not somebody yelling me. Yes, awesome. Thank you, Nancy. So we've heard some really cool stuff today, right? We've heard everything from like UFP-QAP and planning through, data validation and what about low level and what do I do with professional judgment and what in the world is the DoD even thinking about data validation and this new guidelines that came out and everything. And so I kind of want to bring it all together. And I'm going to talk about data usability assessment, yes, but I'm going to talk about data usability assessment in the context of the data quality of the projects that we're doing, right? Like an overall data quality discussion. How do we ensure that we have appropriate data quality? So, okay, big picture, right? Like let's think really big picture. When we go out and we collect data to answer a question at one of our sites, we need that data to meet two requirements. We need it to be scientifically valid, meaning that we understand and have controlled the precision, the accuracy, representativeness, all those parts things, right? In relation to the way we're going to use this data. And we need that data to be legally defensible. Now, I'm not going to talk a whole lot about the legally defensible side of it. That is, related to how did we collect it? Is it traceable? Are we adequately preserving it? Have we ensured the integrity of that data? Have we ensured the security of that data? Right? All that stuff goes into legal defensibility, and I'm not going to talk too much about that. I'm going to stick to the scientifically valid part because that's what I think is fun to talk about anyway. Okay, so where are we going to go today? We're going to start with talking about systematic project planning. And I know we heard a lot about this in the context of the UFP-QAP from Janice several hours ago, right? And it's probably like, oh man, it's like drinking from a fire hose, all this stuff. And then I'm going to talk about why it's important to carefully collect our data. That should seem pretty obvious, right? I'm going to talk about how we determine appropriate data review, how data review works, how we get a thorough data usability assessment, how we make sure that it's documented, and I'm going to show you a couple of examples. So that's kind of where we're going today. So let's start with go forward, please, project lifecycle. So we start with identifying a project. There's a thing that I need to go out and do, right? There's a question that we need to answer. There's a site that we think might have some concern, whatever. Then we do systematic project planning and we develop a QAP. And since we're talking about DoD, we're probably talking about the UFP-QAP in some form or another, right? We're going to have our scoping sessions. We're going to define that problem. We're going to develop those data quality objectives. We're then going to develop a sampling design that's capable of meeting those data quality objectives. And then we're going to determine the measurement performance criteria that we're going to use to evaluate whether that data has met the data quality objectives. And that's all part of our systematic project planning. What are we going to go out there and do? Then we're going to go do it, right? We're going to go out into the field. We're going to collect those samples. Probably collecting some field measurements too, right? Maybe we're even at an MMRP project and we're doing like geophysics and fun stuff that I am not an expert in. Then we're going to send those samples to a laboratory. We're going to get those results, including all of those QC results. And then we're going to get those laboratory data deliverables. All right, I have my data in my hand. What now? Now I do data review. And at this point, we all know, because we've been talking about it all day, there's 3 parts, right? Verification, validation, and data usability assessment. And then once we're done with that, we have a data set that we have said, yes, this is the data with which I will make decisions at my site. And then we're going to make those decisions. And we're going to go out and we're going to take whatever action we need to take, or not take an action because we decided we don't need to, but we're going to make that decision. All right, let's start at the beginning. Start at project planning. Okay, you heard a lot about this earlier. For us, we're going to say that project planning begins with the UFP CLAP. Now, I recognize for my project managers in the room, any of my contractors, I know that there's a lot that happens before you sit down to write that CLAP. I know that there's RFPs and PWSs, and there's determining, like if you're FUDs, which I do a lot of FUDs, like eligibility requirements and all this stuff. But let's just pretend that we're just talking about, all right, we're down to the part where we've got to go plan to go out and do something, right? All that lawyer paperwork stuff is handled. So we're going to write up our CLAP. And as you all know, the UFP CLAP used to be 37 worksheets, now it's 28 because they're optimized, right? And they're organized kind of in groups. And so I like to think about it as worksheets 1 through 8. Those are kind of your like management. That's like who's doing this project, how are we going to communicate with one another, what are our requirements for training, who's read this thing and approved this thing, right? It's all that management stuff. Worksheet 9 is our planning sessions. This is where we document, hey, this is how we made all of our decisions. This is how we did all of our planning. 10 through 16, those are our project objectives. These are our conceptual site model. How do we get our DQOs? What are our performance objectives going to be? 17 through 30, how are we going to go out and collect that data? 31 through 33, or how are we going to perform oversight of the project? And 34 through 37 are that data review. Now, without getting into too much detail about this, there's some really cool references to help you with this stuff. You've already heard about the UFP CLAP, all the different parts. One that I underappreciated for a long time, but I actually think everyone should just like go read tonight, right? Before bed, sit down, print it out. I promise it won't put you to sleep. But it's part 1. It's the UFP CLAP manual, and that really tells you how to write a CLAP. And it's a lot of context for those worksheets that is really super helpful, especially as we talk about data usability assessment. Of course, those optimized worksheets, the ones from 2012, great. And then also, if you've never looked at it, EPA QAG 4, which granted is about 20 years old now, but this is the guidance on systematic planning using the data quality objective process. And this is a really in-depth, step-by-step, how do we do good data quality objectives? And one thing you're going to hear me say at the end, so I'll say it at the beginning now, is when we get to the end of a project and we're holding a data set and we just don't know what to do. We just don't know how to make that decision. 9 times out of 10, maybe even more, it comes down to, well, we didn't have good DQOs. We didn't really define the data we needed and how we were going to use it up front. And now we're holding this data set and we're not sure what to do with it. So really taking that time to understand the DQO process is super helpful. So here's the DQO process. I'm not going to go into any level of depth that is going to be really all that helpful, but I do think it helps to have this context here. So the first thing we do is we state the problem. What is the problem we need to solve? This is a high-level thing, right? This is, there might be contamination in the river, right? It's like really high level. Step 2 is identifying the goal. Now we're saying, okay, what are we trying to do about it? We're saying, we need to determine whether contamination in the river sufficiently exceeds thresholds such that a cleanup is necessary, or whatever. right? It's still pretty general, but we're getting a little more specific about what data are we going to need to solve this problem? What are the possible things we might be able to do about it? Step three are our information inputs. What are the possible data that we might need to answer those questions? So, I mean, obviously, in the context of this webinar here, right, we're talking about laboratory data, right? We're talking about chemistry, but there's all sorts of other data, right? There's like land use data and toxicity data and all sorts of other information inputs that we might need. Then we define the boundaries of the studies. That's step 4. Think of these as the limitations we're working under. So that's, yes, things like temporal limits, spatial limits, right? Maybe I can't go out and take samples in the winter because, you know, I don't know, I'm up in Alaska and the ground freezes, right? Or maybe I have to be careful taking samples in the summer because I'm in Florida and there might be a hurricane. But also think about your target population. And this is one that I think sometimes we miss. Sometimes we get it, sometimes we miss. But this is, what are the total possible samples I could be taking? Am I targeting groundwater? Am I targeting surface water? Am I targeting soil? Those are also some of our boundaries. Okay, then we get to step 5, which is develop the analytic approach. Okay, this is one where I think us chemists, and I'm throwing myself into this, we get a little ahead of ourselves. We get out over our skis a little bit because we start saying, I'm metals, so I'm going to do 60-20, and well, I'm at an MMRP site, so I know that there's a preference for incremental sampling. So I'm going to do. That's not what this is. This here is our decision rules. This is us saying, are we making a decision about the site above, below? Are we making an estimation where maybe we're saying, the average concentration is, you know, within these limits in order to do, you know, risk assessment or something like that. These are our if-then statements, okay? This does not necessarily yet have to do with how, you know, what methods we're going to use or things like that. Then we get to step 6, specify the performance criteria. This is another one where us chemists get out ahead of ourselves. We start thinking about LCSs and MSMSDs, and we start thinking about blanks. That's not what step 6 is. Step 6 is saying, okay, there might be unacceptable risk. I have to decide whether there is or not. How right do I have to be at that decision? If I say there's no risk and there was contamination, then I'm going to walk away from it. So is a 1% chance of that sufficient? 5%? You know, on the other side, if it's in fact pretty clean and there's no risk, but I say there is, I'm going to spend money cleaning it up that I didn't need to, that I could have used to clean something else up, that I could have used to solve another problem. Well, how tolerant am I of being wrong in that direction? 5%? 20%? Right? And these are not things that we have hard and fast rules for. I can't sit here and tell you, you know, the government requires that you be 95% certain. I just can't do that because there is no requirement for how certain you have to be. This is a project decision. But you'll see that doesn't necessarily yet directly tie in to our NPCs or things like our LCSs and all that, right? This is how right do I have to be about the decision I'm making at my site. And then I take that step 6, okay? I have figured out what the problem is, what data I need, my limitations of getting it, how I'm going to handle that data, and how right I need to be about my decisions. And now I need a plan. I need to figure out how many samples do I need? Where do they need to be located, right? All of those things. Given all that, like, how am I going to do this? How am I going to collect this data set that I need? And that's where we get into those things like determining our parts, determining our data quality targets. So in order to make our defensible decisions, our data has to be of the right type, quality, and quantity. And you'll see that all over the place in the USP QAP stuff. Type, quality, and quantity. Where do we actually get that? Okay. Well, type, that comes from DQO steps 1 through 4. Remember, we said, what's the problem we're trying to solve? What are we going to, you know, what is the data that we need? What are our limitations? That's the type of data. Quality, well, that's now going to come down to the sensitivity of that analysis, right? The repeatability of that analysis. That's DQO step 6, and also some of our other USP QAP worksheets, 12, 15, 24, 25, probably some others too. And then quantity, how much data do I need? Well, that's also DQO step 6 and very much step 7, and also some other USP QAP worksheets that help you to determine and document it. So, quality, right? I said that was step 6. Yes, we are thinking about NPCs. We are thinking about field duplicates. We are thinking about, replicates. We are thinking about maybe PT samples that the laboratory did. And that's all well and good for a single data point. But remember, we're not making decisions based on one sample, right? If you told me that my backyard is now a site somebody's investigating and they came out and took one sample of it and said, oh, based on this one sample, you're fine, I might be a little concerned, right? My kids play out there, one sample, really, right? I'm going to want you to use a full data set, or in some way tell me how that one sample is representative, right? So when we think about things like precision, accuracy, representative, comparability, completeness, and sensitivity, we also need to think about evaluating it for the data set as a whole. So where precision for a single data point, we might look at something like surrogates, right? Precision of our data set, now we're looking at things like the standard deviation of our whole data set. And we stratified the site and we said that, hey, this whole site is a unit that I'm going to make a decision on. And it's, similar to itself in significant ways where I can say, all right, this data set represents this decision unit. Okay, well, what's the standard deviation of my measurements, right? Did I actually get the precision that I thought I needed? Same with accuracy, right? And we can go down each of these, right? Representativeness, we're looking at things like, did we follow our sampling SOPs? Do our field replicates adequately return such that we can be pretty sure that all of these samples are representative of the site and we've stratified it appropriately, right? Those are great. For the data set as a whole, we need to be thinking about, did we get an adequate number of samples to cover the site? Or if we're thinking incremental sampling, right, did we take our samples in a method that inherently increases the representativeness? And that's where we start doing these. You'll see a lot of these, there's like statistical correlations, right? You're looking at how did that data set as a whole. So please don't forget about that as a DQO. We tend to, man, I do this because I'm a chemist and I love looking at those data points, right? But we got to remember to think about the whole data set. So that's quality. That's how do I know the quality I need? How do I know the quantity? Well, now this is where we really need a statistician to help us. Or, and you'll see I have an example here, there's lots of software that can help you design a robust sampling design. VSP is one that is free. You can go get it. It's from PNNL. And so you can go just Google it. You'll find it. For Army Corps of Engineers, we can get it. We can download it from our little app portal. I do not know about Navy, Air Force, any of the others. Somebody might know and be able to put it in the chat. But it is free software. It's there. But what we really want to know here is that we need a statistically valid sampling design. We can't go out and take our samples at places that we as a human choose based upon some sort of site knowledge and then expect to be able to do a robust statistical comparison of that data to some sort of action level or something. That doesn't mean that judgmental sampling can't meet your DQOs, but it means you can't do the same kind of analysis on that data set that you can when you do a truly random sampling. And I don't think I put it on here, but I think it's EPA QA G5. It's either 5 or 6, guys, I don't remember, that talks about sampling design. And that one's really great too. And I super recommend you read that. Again, I think that's like 20 years old, but it's still a really great starting point to help you understand the different types of sampling procedures, or not procedures, but approaches, sampling approaches, and why you might want a judgmental sampling approach, why you might not, the different types of random. But the key inputs to how do I know how much data I need are going to be, what am I comparing my data to? How well I want to control for those decision errors, and that anticipated sampling and analytical variability. So this is like, some of it's coming out of the lab. We now probably understand that most of our variability is coming from the site conditions and not what's happening in the lab, but that's going to be an important input. So that's how we know where these things come from. And why am I spending so much time talking about this? Like planning stuff, I should be talking about data usability assessment, but that's because, as you're going to see in a little bit, the first thing the data usability assessment does is go back and look at your DQO. So we need to have a good understanding of where our DQOs come from. Okay, so that's cool. We did all our project planning and we got all the signatures on it and we're all happy with the plan, and now we got to go out and do it. And how do we assure that data quality? Well, we're looking at our field activities, we're looking at our lab activities. I do not need to tell this audience about laboratory data quality. This slide is an abbreviated version of a slide that I gave in another presentation. I just wanted the reminder, we all understand how the QSM works, right? We know that it's built on ISO, we know that there are T&I requirements, we know that the QSM is built on top of those. We understand that the QSM is published by EDQW. We know that it has minimum quality requirements for laboratories, that it's accredited by third-party accrediting bodies. We all should probably remember that it does not include anything that happens in the field, right? So our field sampling, and it doesn't, the QSM and laboratory accreditation in and of itself doesn't ensure that our specific data points for our specific site have met those requirements. It means the laboratory is capable of meeting them. All sorts of stuff can happen in the lab, in the field, in the matrix, whatever, right? And then remember that we need to be thinking about the data quality during our field activities as well. Adhering to our sampling plan, documenting when we deviate, following the SOPs, collecting those field samples. And then don't forget your field measurements should have some measure of or understanding of the quality associated with them as well. We use those field measurements to inform our decisions, inform our actions. So we should be, in some way, understanding the quality of them. Okay. So I said the mere presence of accreditation doesn't mean your specific data point's going to meet that, right? All sorts of stuff can happen. How do we ensure that? That's data review, right? That's like one of the most fun parts, maybe. Maybe the chemists in the room agree with me, maybe they don't. So I love this flowchart. This flowchart comes from the USP-QAP manual. I've added the colors. But this, I feel like, is a really clear way to explain what goes on in the data review process. We start with verification. This is everything there? Did I get it all? And then there's a report, probably a checklist, right? Then we do our validation. The USP-QAP manual breaks up into like validation 2A and 2B. We kind of roll it all together. But the point is, was this data generated in compliance with underlying specifications? So that's a QAP, a published method, an SOP, whatever. At the end of that, you get a report. We should be doing some level of validation on our field measurements as well. You know, the extent of that is going to vary a little bit from project to project. And then we move on to the third step, data usability assessment. Now we take all that stuff that came out of validation and also our historic knowledge, right? What has been going on at the site? If this is an LTM site and we've been out there 15 years, we've got a lot of historic knowledge, right? Any field observations, those records, any of that stuff. We bring all of that in, we bring all our experts, and we say, hey, does this data meet the type, quality, and quantity that we said it would? Then we get a usability report, and yay, we're done. So I get this question a lot, and I especially get this question from like project managers and people who aren't looking at the data, and they say, what's the difference, right? Like, I still don't get the difference between validation and usability assessment. So, general way to think about it, right? Verification here ensures presence and completeness. The person doing it is probably going to be the prime contractor. It kind of varies based on the data type. It covers all project records. Everything is going to be verified, right? Because I need to make sure I got all that data.
Now, do you have my audio back?
Yeah.
Oh, but I
can
can't hear
Melinda.
you if you're oh, you can hear me. Cool. Okay. See, that's again connected with multiple methods because my phone just dropped. Okay. So, everything needs to be verified to make sure that we got it. That's part of that like legal traceability, right? That legal defensibility. Validation looks at, like I said, compliance with underlying specifications. This is done by, and this is, I probably shouldn't even have this say third party anymore because there was so much chat about it. This is done by not the lab. The lab doesn't validate their own data. Your project will decide what level of validation or like who's going to do it. But the point is, it's not the lab. It is, however, probably one entity. Might be one person depending on the scope of your project, or you might be going out to a larger firm where they have an organics person and an inorganics person, etc. Or they may even get down to like the method level. But it's like one person looking at the data and the underlying specifications. Usability assessment, on the other hand, says, okay, let's take this data and let's compare it to our DQOs, to our parks. And we need the whole team. Everybody needs to be involved in that in one way or another. And we do this at the end of a sampling event before we make a decision. Every time we're making a decision about our site, there should be some level of data usability assessment to determine whether we're capable of making that decision. So that's the difference between these three steps. Okay. Again, probably don't need to tell this audience this information. You probably already know this, but as a reminder, data validation is done in stages. Stage 1 is our sample results, our sample receipt summaries, our field QC data. It's, the lowest level of validation we can really do. Stage 2A and 2B, now we're getting into batch and sample specific QC and instrument QC, but we're still only looking at summary forms. We should not at 2A and 2B have to go back to the raw data. At stage 3 and 4, that's where we start to look at the raw data. It's where we start to do recalculations. It's where we start to do those qualitative evaluations of, chromatograms and things like that. So I get the question, well, how do I know what stage my project needs? Well, it kind of depends on your DQOs. It depends on your tolerance for uncertainty. Remember, a higher stage of validation is not necessarily going to result in any higher data quality. The data are what the data are, right? The QC is what it is. What a higher stage of data validation is going to give you is confidence in your evaluation of the quality of the data. You will have more confidence that you've found issues or that there are no issues or whatever. So it then becomes sort of this, and unfortunately, it is a little bit qualitative determination of what stage do I need. There are some, general recommendations. I think they vary so much by program. I'm just not even going to get into them, but that's in general how you decide. Then we get this data validation report. And this is prepared by the validator. It identifies what laboratory SDGs, what analysis were included in each one. There should be a cross-reference between our field sample ID and our laboratory sample ID, right? Because I know what samples I took out in the field and I know what MW01 means. I don't know what the, laboratory sample identifier means. So I need some crosstalk between those. It's going to tell me how it did the validation, and it's going to give me a qualifier. You guys know this, right? And here's a list of qualifiers. I believe this exact table was already shown once today. We don't need to go into it. But just remember, the report's going to include, findings, checklists. It's also going to have probably an electronic data deliverable associated with it. Okay, X qualifier. I'm not going to read this whole thing. This is straight out of the general data validation guidelines. The long and short of it is, data validation doesn't accept or reject data. Because remember, the data validation is one person, one entity, whatever, looking at the data. In many cases, not all cases, but in many cases, that person looking at the data will not know anything about the site. So they don't know. I think an example that was given earlier was like, oh, we have 10 years of LTM data. The validator might not know that. And yeah, if the project chemist is the one doing the validation, they probably know that. But not always. And so it's not the role of data validation to accept or reject the data. Okay, well then, but who does that? Right? Validation can't. They're the ones looking at the quality of it. Who rejects the data? That's data usability assessment. That's what data usability assessment is about. It's about accepting that data that for use or saying we can't use that data. Validation is an input to it. Usability is, are we going to use it or not? All right, how do we do it? Cool, Melinda, you've convinced me we need to do this thing. How do we do it? Okay. First, you have to assemble the group, and this was already talked about as well, but you're going to have each entity. So the lead organization, oh, and I borrowed this slide from a different presentation where the lead organization was always USACE. So in this case, it's not always USACE, ignore that. The lead organization, which is probably the government, right? Any stakeholders or regulators, the contractor, and appropriate subcontractors. Okay, they're each going to bring their own subject matter experts to the table, and that could include, well, it better include the project manager. And if there's a separate technical manager, it probably better include them too. And then it's going to include other subject matter experts as needed. So we're talking about chemistry data. You're probably going to need your chemist there, right? I gave this talk to the M2S2, and sometimes they don't take chemistry data, in which case you don't need a chemist, but they're taking geophysical data, so you need a geophysicist, right? Maybe you need a geologist. You probably need a risk assessor, right? There's all sorts of others you could potentially need here that aren't even listed. One that people often mention is like archaeologists. If you have a site where you have potential, cultural resources there, you probably need somebody who can look at that. What about our field samplers? Do they need to be there? Well, I mean, I at least need their notes, right? Maybe I don't need them sitting in on the meeting. What about safety personnel? Well, again, I might need their notes. One of the things of data usability assessment is lessons learned, but maybe they don't need to be in the room. But if it's like an OESS, maybe they do because they're more involved, so this is all customizable, and it's going to be detailed in worksheet 37. And then we're going to look for ways to maximize those resources, right? Can one person, or is one person serving both of those roles? Do they have reports that we can send out and reference ahead of time? Because remember, what we're doing here is we're all protecting human health and the environment. That's our goal, right? We're not here trying to make the site be clean. We're trying to get the right decision with the data and have that data be legally defensible and have known and understood quality. What do each of these people do? So the government personnel, you're going to have the project manager. This person is the one ultimately responsible for getting the DUA done, right? They're ultimately responsible for all of the project activities. They're going to delegate. Our PMs are real busy. But in the event that there's ever disagreements that can't be easily resolved, they're going to make sure that those are resolved. They're going to make sure that each person got to say their piece. Technical manager, similar way, right? They're bringing that broader technical viewpoint. They're putting all that data into the context of who's asking what questions. And then all the other SMEs are going to do their subject matter expert thing, right? They're going to bring the things they reviewed. They're going to bring their findings from their review, talk about what they see and how that means in the context of everything else. Okay. Contractor, it's similar, right? But they're now bringing in their own subject matter experts, and they were the ones probably, boots on the ground doing the work, if we're being honest, right? And they were probably more in-depth in the nitty-gritty of what was going on. They're probably also the ones preparing reports and bringing those draft documents. And then finally, regulators and stakeholders. So this is one that I always find fascinating to talk about, because I go out to some places and I say, hey, your regulator should be in your DUA meetings. And they say, my regulator won't do that. They do not want to participate. They only want to comment, to draft documents and provide, their input that way. Okay. Cool. Well, we can work with that, right? You can write it into your worksheet 37. This is when they're going to get the drafts, and we're going to offer them these kinds of ways to participate. And here's how we're going to hear them out and all of those things. And then I go other places and I say, yeah, your regulator might not want to be there, but, and they say, oh, no. Jim is great. He always participates, and his office, okay, well, that's awesome. That's wonderful, right? So the way in which they participate is going to vary, but we really recommend that you get them involved early, get them in these discussions. They're going to have viewpoints and context and information that is really going to help you to, have a better product at the end. Okay, Logistics for a minute, there's multiple ways to do this. Obviously, you can have an in-person meeting, right? One person schedules it, everybody shows up, you've probably got coffee and donuts. These days, you're probably not doing that. You're probably doing a, virtual meeting. And so you're scheduling it, you're all, hopping onto the Zoom or whatever, and discussing the data usability assessment. And then there's another option, and I mention this, but I hesitate sometimes. I have seen this option work really well on very simple, very straightforward projects where there were no QC exceedances or issues whatsoever. And yes, I have been on one of those projects. But this is where you do the data usability assessment like asynchronously, right? You prepare a draft document, you get comments back to it, you discuss via email, you resolve issues that way. It can work if things are very simple. Once you start having to have those more complex discussions, once you have to bring in multiple disciplines to talk about something, it's probably better just to talk about it, right? But it is an option. Okay. And now you're thinking, well, that's great, Melinda. You've told me how to do it, but you haven't actually told me like how to do it. You told me how to get in the room and who needs to be there, but like how? Okay. And this is where we get to the 5 steps. Or is it 4 steps? Well, that sort of depends. Like I said, I gave a very similar presentation recently at an M2S2 webinar, where they're, of course, talking more about munitions. And so they're talking about the MRQAP, the Munitions Response Toolkit. And that Munitions Response Toolkit, it follows the format of the UFP-QAP. And so worksheet 37, there is data usability assessment. It has 4 steps. But if you go look at our 2012 worksheets, you'll see 5 steps. Well, what the heck, Melinda? Okay. The point I want to show you here is that whether you're following 4 steps or 5 steps, you're doing the same thing. The first thing you're doing is you're going back and you're reviewing your project. You're reviewing your planning. What did we think we were going to do? What were we planning on doing? What kind of data did we think we needed? Then step 2, you're reviewing the data itself. What does it look like? Then you're doing some math. You're applying your decision rules. You're doing your statistics. You're doing that math stuff you said you were going to do early on, right? If maybe you're taking an average, maybe you're doing a 95% confidence interval on the mean, whatever you're doing, right? And then finally, you're documenting it. You're documenting what you did. You're drawing your conclusions. You're making your actions. Okay, these are the 5 steps. So let's go through them. So I'll also point out one more thing, and then we'll talk about it. If you go all the way back to EPA QA G4, the DQO guidance I mentioned, I'm sorry, not that one. No, EPA QA G9 is on data usability assessments. They call it data quality assessments, but it's data usability assessments, the same thing. EPA QA G9 is this same process, and it also has 5 steps, but they're in a little bit different order. And that is because at the time that one was written, we could not assume that you had good DQOs before you took the data. By the time we get to 2012, we assume you do have good DQOs before you take the data. So I definitely recommend reading that document as well. Awesome, awesome document for guidance. It goes into a lot of statistics, which is a lot. But definitely the very front of it is really helpful for these 5 steps. You'll notice they're in a little bit different order, but that's why. It's still doing the same stuff. Okay, so step 1, review project objectives and sampling design. I like to think about this as questions, right? When I'm doing step 1, I'm saying, what were we trying to do? So I'm going to go back and look at the conceptual site model. Do I have any contradictory information? Did anything that I collected this time, does it call into question anything I thought I knew about the site? Now I'm going to look at DQO step 1. That's my problem statement. Was my problem statement correct? Were my study questions complete? That's step 2. Did I identify all my necessary data inputs? Or as I was executing the project, did I realize, oh, we actually need additional data that I didn't identify here? If that happened, I'm going to need to figure out DQOs for that data to determine if that data can be used, right? I can do it after the fact. It's possible. Did I identify all the boundaries? So you can see how I'm going through the steps, right? Step 5, and this is a bunch of questions, and I put them all in one because I wanted the whole bullet to represent one step, and I know it's a lot to read. But was my data collection approach appropriate? Did I specify my decision rules, right? If my data shows this, I'm going to do this. If it shows this, I'm going to do this. And sometimes these decision rules can get quite nested and complicated, right? But did I identify all my possible outcomes, all the things I might do? Did I have sufficient NPCs to address those? And did my sampling design address everything? Did I do that data reduction in accordance with those specifications? All of that stuff, right? And basically going back through all the planning I did and saying, did I do a good enough job with my planning? Okay. Step 2, now I'm going to look at my data verification and data validation outputs. So now I'm saying, look at all the data. What do I have? This is the part that I think it seems pretty obvious a lot of the times. But gather all the data. Did I have any exceedances of my measurement performance criteria? Did I reference the right ones? This is something where we talked about, like, hey, if you've changed them from what the standard might be, you might want to call that out ahead of time, right? So you're not going back and repeating that work. Did I follow all my procedures? If I find that anything unexpected happened, well, what is the impact on an individual data point? What is the impact to the data set as a whole? If I have a data set of 100 points and 3 of them are estimated, am I going to impact that data set as a whole? I mean, that's a question for a statistician. I don't want to say yes or no, but that's different than I had a data set of 5 points and 3 of them are estimated, right? We can see how the impact, even though the impact to an individual data point might be the same, the impact to the data set as a whole might be different. Oh, okay. So that's step 2. Step 3 and 4, this is where we do all that math stuff, right? So whatever statistical method we were going to use, and yes, over under is still a statistical method, right? A straight above below, I'm not going to put error bars on it. That's still a statistical evaluation of a kind, right? They all have an underlying assumption. It might be something like, hey, I assume that my data is going to be normally distributed so that when I take those standard deviations, they adequately represent, my population distribution. But environmental data often aren't normally distributed. And you very quickly get into a case where you need some help from somebody who understands that data a little bit better. Or maybe you're assuming, you're going to look at 2 different analytes and you assume that the concentrations of those analytes are independent of one another, but actually they're dependent on one another, right? As one goes up, the other goes up, or as one goes up, the other goes down. And your evaluation assumed it wasn't that way. So now we need to think about that, right? We're looking at all of this. What do we intend to do? What are the underlying requirements of that data set? Hopefully we identified those during DQOs. If we find that something went awry here, we need to pick a new method. We need to pick a new comparison. Or I guess we could decide we can't do a comparison and we need to go collect more data, but we need to do something different. And this is where we pull in, make sure we've got the right experts. If everything's good, then we do it. We analyze the data, right? We do the thing we said we were going to do, and we document both the result and our level of certainty, right? And this gets back to our DQO step 6 and step 7, where we said, how right do we have to be? How wrong can we tolerate being? Okay, what is our actual achieved certainty? We said we needed to be 95% certain. Did we get it? And then we document the decisions. So, did we learn any lessons? What decisions did we make? We write up a data usability report. What does that report look like? Okay, I'm gonna ask you guys, see, I like doing this in person because I can get like hands up and stuff. So I guess, I don't know, give me like a thumbs up or something. Have you ever seen this? Where you're reading a report and it says data usability assessment, and then there's a paragraph and it looks like this. 100% of the data validated are suitable for their intended use. No systematic accuracy or precision trends were identified. No sample results were rejected. Sample results that were qualified as estimated or usable for project decisions. The completeness goal for the number and type of sample requirements were met. How many of you have seen that? And that's the entirety of the data usability assessment report. I'm seeing quite a few thumbs up. Yeah, I think we've all seen it, right? So I'm gonna ask you, based on that paragraph above, can you tell, did you review your systematic project planning? Did you review the, how did you review the type, quality, and quantity of your data? What QC exceedances were noted and how did they impact the data set as a whole? No, you can't tell from that paragraph. Now, does this mean I think they didn't do it? Not really. I like to think they probably did, right? They had those conversations, they discussed them, they made their decisions. They just didn't do a very good job of documenting it. And here's the thing, guys, if it's not documented, in 30 years, it didn't happen. So when all of us on this call right now are retired in 30 years, and somebody's going back and evaluating the decision that the government made at one side or another, they're not going to be able to tell how good that decision is unless we have this adequately documented. So what do we do instead? We do a data usability assessment report. We write down those things. We say what data we reviewed. We go through the 5 steps. We discuss any deviations. We clearly state our conclusions. All those steps that I talked about, we just write it down. And then we include it as an appendix to whatever report we're writing for the site, just like we do with our laboratory reports, just like we do with our data validation reports. We include that data usability assessment report as an appendix. And within the body of the report where we're talking about the findings, we say, hey, these were our decisions. If you want the full discussion, the full technical justification, go look at appendix, K or whatever. It also can be in line in the whole report. I don't really care as long as it's there and it's traceable and it's documented, right? An appendix is usually the easiest way to do that. So for fun, let's look at a couple examples just because we can. So this is an HTRW remedial investigation report. Okay, so they have a data usability assessment evaluation appendix. That appendix looks like this, and I've taken the identifying information out. But as you can see, they have step 1, here's what we did, and here, yes or no, and comments about it. And step 2, and here's what it is, and yes or no. And then even within this overall section, they then say, go look here for more detailed information about this. Or look, this is, hey, do we have new information to the conceptual site model? Yeah, we updated it. Go look at section 6, right? This is great. It clearly shows the findings. It clearly shows the impacts on the data. And then this is the table of contents where you can see they've broken it out by what did we review by SDG, which QC parameters. Look, we evaluated each of the parks, right? Conclusions. And then it has a concise conclusion, which states, here's what we're doing for the site. Let's go do it. So can we see how this is significantly better than that one paragraph? Right? Another example, this is an MMRP example. Again, I've made this anonymous. But they have a data usability assessment summary, which has a bunch of information that I've blacked out so you don't see it. But it has all the SDGs, it has information about the data that were reviewed, it has some information about what was accepted and rejected, narrative comments. Then it has a checklist. I know this is too tiny to read, but the point here is that this checklist addresses each of the 5 steps of the data usability assessment process. And then it's like a yes, no, and then narrative comments in there. And then it also incorporates references to data tables. I know, again, too small to read. The data tables, I'm not showing it here because it was like a huge project and so much data. It was just page after page after page after page of data tables. Obviously, that lives in a database somewhere. It's a little bit easier to use that way, but it exists in the final report. It's preserved there. And it indicates where our qualifiers have been changed following validation. So any of the X's, or one thing I talk about sometimes is like, sometimes your validator won't know that there's a problem with the data because everything was fine in the lab and the problem happened earlier than that. They can't possibly know that you took the sample at the wrong site. And so the team decides to reject it because it's not representative, it was taken at the wrong site, but the validator couldn't possibly know. And so it does indicate those too, where even though validation showed it was fine, they still had to reject it. So that's it. That's how we got there, right? We started with our systematic project planning. We did a really good job with our DQOs up front. We really dug in. DQOs take a long time, you guys. It really does, but it's worth it. Every minute of it is worth it. Then we did the activities we said we were going to do. Then we did the review, and then we made our decisions. And everything is beautiful. We had a wonderful DUA process. We have these defensible decisions. Right? We have adequate data quality. We have consensus from the whole team. It's great. So I'm happy. What time is it? I'm 3 minutes over, but I'm happy to take any questions anyway, because I think technically we scheduled till 3:30, 4:30. Let me see if I can get the Q&A or the chat open while I'm sharing. I don't know if I can. I can get the chat. I don't think I can get the Q&A.
I can read the Q&A to you. Any that pop up in there.
Yeah, I could also just stop sharing, I suppose, but maybe I'm going to want to go back and reference them. So yeah, tell me what's going on in the Q&A.
Yep, pulling it up right now. So, of course, a little slow. So, first question we have, is a DUA meeting a requirement?
Is a DUA meeting a requirement? That is a fabulous question. Okay. A data usability assessment is a requirement. The first mention of data usability assessment for environmental projects is from 1992. And then it definitely exists as of 2001 when the UFP QAP came out. So the data usability assessment itself is a requirement. Do you have to have a meeting? That's a project decision, right? What complexity of data are you going to have? How difficult is it going to be for you to evaluate all that data? How many different people need to come together to help make that decision? And what's the most efficient way to do it? I think when you get beyond the simplest projects, the easiest way to do it is a meeting. And I've done these in like half an hour for an event. Hey, here's what we found. Here's what I want to reject. And here's why. Yeah, okay, we all agree with it. Yeah. One of the things that really helps those meetings run smoothly is if you have a draft document prepared going into it. So I would recommend that, probably the contractor prepare that draft data usability assessment report going into it with their recommendations or their determinations of what should be done with the data so that you have a starting point for discussion. And then everybody can review it ahead of time. That helps it to go really quickly. Okay, and then I can see this other question. Where is the justification for final X qualified results? Okay, so multiple parts. So what do we do with X qualified results? So the data validator has put an X on it. That's where the data validation report ends, right? They put an X, they said, here's why I did that. Here's where it came from. I really love it when a data validator says, like, as you can see in page 1234 of the laboratory report, because those things can sometimes be huge, right? Because that helps me to be able to go look at it. Not a requirement necessarily. But that's where the validation ends, right? Is at that X qualifier. The data usability assessment team then takes that X qualifier, and there should probably be a discussion somewhere within the data usability assessment report that says, hey, here's the data we talked about. We had to discuss all these X qualified things. Here's what we did with them and why. We rejected them because, yes, the deficiencies are so bad that they can't possibly know. Or, we decided to use them as an estimated value because, maybe it's like, maybe you're looking at like, I don't know, like lead and copper, and the lead is like all the copper is X qualified, but the lead is like 2 orders of magnitude over your screening level. We're not going to go back out and take more samples because that's not a good use because you got to remediate anyway, right? So maybe you're like, well, this is where it is, and we're going to use it just as a, very limited use input for the future kind of deal, right? You can do some things like that to make best use of your resources. How do you document that qualifier change in EDDs? That's going to be really dependent upon your database Anyone who knows me knows that I could talk about FUDSChem till we all fell asleep, so I can tell you how to do it there. You mentioned NIRIS, ERPMs. I'm less familiar with NIRIS and ERPMs. Yeah, you're going to have to ask somebody who works with those databases. In an ideal world, right? You've probably got three columns. Let's say you've got, here's what came out of the lab, here's what the validator said, here's what our team decided at the end. And you know, you put it through that way. I saw somebody say that NIRIS doesn't take X's. That might just be a valid value issue. And that's a discussion to have with them. Like I said, it's going to be dependent sort of on your particular database, but in terms of like what would I expect to see in a report, I would expect to be able to see somewhere in that report, here's what the laboratory said about this data, here's what the validator said, here's what my team decided, and then probably some sort of summary data table lives somewhere that says, this is the data we have decided we are going to use to make our decisions. You know. Are the examples with the checklist available for public review? One of them is, but only because I stole it out of FUDSChem, and the FUDSChem documentation is just available. You can just go look at it, and it has the checklist there. The other one, I don't know. I mean, you can see what they had there. I think that was I mean, I'm sure that report got published, right? It's probably part of the administrative record somewhere. But yeah, specific checklists, not necessarily. I mean, what you can do, right, is if we go look at really what happened is we take, let's go back to here, right? We take, you know, this of here's all the things you do, and we turn them into just questions, right? Like, were MPCs achieved, yes or no? So that's where that came from, probably. Question from the chat, just confirm the prime contractor can be the data validator as long as they are not the lab. Again, it's a project-specific question, but per our guidelines, yes, the lab, as long as it's not the lab validating the lab's data, it's okay. Now, your particular project may decide, hey, for one legal reason or another, like, I don't know why, we don't want to do that, and that's fine. But per our guidelines, per our definitions, yes. Okay. Who selects the statistical analysis? Well, if you're signing off on the QAP, right? If you're a reviewer to the QAP and you're signing off that, yes, this is what we're going to do, then you are signing off and saying, I think that this statistical analysis is appropriate, right? It's the project team. I would absolutely want the chemist on the line. I would want the risk assessor in there, right? If you have access to a statistician, that is amazing, especially if you're doing any more complex statistics than, you know, simple statistics. But you select your plan for it at the beginning during systematic project planning. You know, this is the data set we think we're going to get. You know, we're comparing to a regulatory threshold that is specified as a mean. So we're going to go get a mean, and in order to be conservative, we're going to get the 95 upper confidence interval on that mean. And so that's how we're going to go forward. And we, you know, one of the underlying assumptions is that it's normal data. So you have all of that, you plan it up front, that's the win. And then on the back end, now you go back and you look at that data and you say, you know, how good are those data? Do we in fact see a normal distribution or what have you? Anything else? Man, I love talking about this stuff, you guys. It's so fun. Right. I don't see any more questions showing up in the Q&A. I see a hand raised. I don't know if we can take you off mute. Oh, maybe you took it down. Maybe that was an accidental click. Okay, well, I will stop sharing my screen now then and turn it back over.
Okay.
But
Awesome.
thanks, everybody.
Thank you so much.
So fun.
Yeah. Thank you. All right, everyone. Well, that wraps up our webinar for today. Thank you again to all the presenters for just the wonderful information you were able to share with us today. Thank you for all of our attendees for sharing an evening with us, and we appreciate it. Like we said at the start, the recording of this will be distributed on our Denix website, and we will be able to get that out soon. So again, thank you all for attending our webinar today, and have a great day.